Okay, I think this was mentioned in your P1, P2 topic presentations, right? Just noticeable difference. Do you recall where it was pointed out, by who and by who? We can clearly distinguish between them in any kind of sense, right? Okay, visually you can see and then even estimate that the smaller square is about half the bigger square. Suppose you are lifting weight, okay, you can clearly differentiate between a bag that weighs 10 kilos versus a bag that weighs 20 kilos, right? And then you will also be fairly accurate in estimating that this is twice as heavy as this one, right? Now, can you do the same thing with this? The difference is the same. Okay, you are lifting a 100 kg bag versus a 110 kg bag, okay, and the difference is still 10, but you will not be able to be as accurate as the first case. Okay, in fact, you might not even notice a difference because it is so heavy, and the difference for the initial in proportion to the initial stimuli, which is the weight, right? It is so small that you will not be able to notice it at all. Okay, and that is precisely what happens when you are reading lengths in any visualization. Okay. Now, something like this, okay, these are unframed and unaligned, harder, okay, these are framed and unaligned. So, mostly you will end up with something like this, right. So, here you are estimating this difference, right, between this data value and this data value, right. It is much harder because the stimuli is very high here and the just noticeable difference is so little, right. Now, which is why we use grid lines. Okay. What does a grid line do in this case? If you use a grid line, what does it do? It increases the stimuli that is required to notice the difference, right. So, it will have a grid line here, it will have a grid line here, it will have a grid line here, it does not matter, right. Wherever the point at which they have become substantially different is that you can ignore everything below that and then look at this one, right, and then you will be able to notice and then you might be able to estimate it better, right, which is why we use grid lines. Okay, so this is a data set of a bunch of cars that are plotted along two variables, the weight of the car and the fuel efficiency of the car, right. So, what you are seeing is that the heavier cars are also less fuel efficient. Okay, lighter cars give more miles per gallon. Okay, MPG is miles per gallon, right. But then the initial plot is like you have these overlaps and all that. I think Rasagi also talked about how we solve this overlapping data points, right. So, you introduce things like opacity and play around with it and kind of so that people can distinguish between each of them. Okay, in this case you make it smaller, introduce grid lines so that you are kind of able to see it, and then even distinguish the type of grid lines, right, not just every 5s and the 10s are different from the 5s and so on, right. So, you're just that much you're reducing that cognition. Okay, so all this happens through a standard process of design we all do, right. So, you all come up with the first cut of the visualization and then it requires iteration, right, where you are trying out and then tweaking these visual variables until you get the right representation, right, that gives you the most accessible form of interpreting the data, right. So, you can start with something like this where all the grids are all done, you have the x axis, you have the y axis and so on and so forth, but then you can you do something about visual clutter, say can we reduce this, and then producing these two lines at the end, is it enough, what about the values that lie in the middle, right. Maybe the background is not required, in the contrast you are improving the contrast, you remove the lines on the left and then you introduce lines like this, right, which is again with the you merge the line with the background, right, so that it does not take your attention. Okay, a black line versus a white line makes so much of a difference, right. These are some works by Tufte. I'll just skip it. So, essentially that is the first part, right. It's just about detection, right, in detecting elements, the ability to detect elements, and then how do we focus people's attention to certain things on the screen. Okay, is the first part, the detection part, right. Now, the assembly, as I mentioned, is your standard graphic design 101. I don't have to tell you about it, but I'll quickly go through the slides. Now, Gestalt is a very important part of how we perceive, right? So, this is the background to Gestalt. You all know about it. A bunch of German psychologists got together and proposed this set of laws. It is called the law of pragnance, or the goodness of an image, right? The pithiness of the image, right? So, that is what Gestalt means, right? How good is an image, right? How pithy the image is. And they said that things are organized spontaneously and assumed to be in the simplest configuration. Okay, and this is very important. Perception as organized and structured wholes rather than their constituent parts. People see the whole rather than the parts. Okay, we perceive the whole, not the parts. And the visual properties are always emergent, holistic, interdependent, and in context. Meaning that we don't isolate a visual variable and read it, right? We always read it in the context, right? So, a color in the background of other colors, right, or next to other data. So, it is the emergent property of the visual representation that we perceive, not in. So, individually you might have taken a lot of care to match the visual variable to the data attributes and made sure that all of them, but together they may not come as a whole. It might not work together, right? So, we should keep in mind what is the emergent property of the entire visual that you are creating, right, and that is what ultimately makes the impact. So, emergence, this is the property that I was talking about, our uncanny ability to read extremely noisy information and make sense of it, right. This is a very famous photograph or a picture that has been high contrast photograph, right, improved contrast to a level that the information is missing, a lot of information is missing, but then you will be able to see that, and once you see it, you will not be able to unsee it. What do you see there in that picture on the left? Okay, a dog that is sniffing the ground, you can see that, you can see the splotch. Now, this ability for the human perception to stitch together this random bunch of splotches and then see an animal there is an amazing ability, right? And one has to wonder that why do we even have such an ability, right? Because it was directly related to the way which we evolved, right? We lived in dangerous environments where to work with such incomplete information and perceive the dangers, right, from predators was very important to survival, right? So, the progenies of those that survived actually, the parents of the progenies, right, passed on these traits, right, and then we continue to have these traits. So, in an urban setting, we are all living here, maybe this is not so important to us anymore, but then we have this long lineage of these traits that has been passed on to us, right. So, imagine you are in a jungle, right, and a predator is behind a tiger or a lion is behind the bushes, right, and is ready to attack you. And you only see these splotches of this yellow color behind a bush, and then you need to be, in a fraction of a second, put those splotches together and then figure out that it is a lion that is running, and then you run, okay, instantly, and then you survive, right. And if you manage to survive, then you had that sensibility, you had the senses, and then you pass down those genes. So, a lot of these are examples of emergences. Now, law of invariance is important. You might not have read it, come across it, as it's not as commonly. So, the mind recognizes simple objects interdependent of rotation, translation, scale, deformation, and light. So, we know that it is the same object in all the cases, irrespective of the scale, the distortions that it goes through, or the different types of rendering that you might use to represent them. Okay. Proximity, similarity, closure, enclosure, right. So, anything that is enclosed by something, is perceived to be together, right. So, all these inserts, boxes, all this ways of separating and highlighting and then, emphasizing. So, the image on the left, we always see that as a horizontal line intersecting a vertical line, right. Rarely do we describe it as 4 lines meeting at a point. Okay, we will never see that as that. Figure on ground, so this is what about network diagrams and all uses very commonly, right? Connected entities, okay, are perceived to be together. Okay. Now, the strength of connections can also be depicted by the thickness of the lines. Okay, so some of the great works of art, the art that appeals to you, right? Not because somebody told you these are art, no. So I mean, we are gravitated towards things that are beautiful, right? It might have makes us happy in some sense, right? You will find that there is a gestalt that governs it, and there is a pithiness and the wholeness to that image, right? That makes us happy, irrespective of whether you are trained in art and art appreciation, etc., right? So, why are these paintings or photographs or pieces of artwork great is because you will find some inherent gestalt that is working there and makes it beautiful. Okay. So, look at this, these are works by very famous artists, either photographers or painters, and there is I mean, I will leave it to you to figure out what gestalt is in these things. So, this is very interesting because it is problematic, right, and it violates a very fundamental gestalt here, right, and what is that? Proximity, right, because the proximity is ambiguous here, right. You have two directions and two labels, but because of the position you are not sure which direction symbol corresponds to which text. Okay. So a better proximity would actually resolve this visual conundrum. Continuity, okay. Common fate, similarity, okay. There is a lot of similar elements, used together to create this, holistically amazing picture. This is a famous Beatles crossing picture, common fate, right. Very, very nice gestalt here, and which is why this picture is so famous. And Escher played around with figure on ground. Basically, he challenged us, I mean, this is what we are not supposed to do in visualization, right? We are not supposed to confuse people with figure and ground, right? It is not a good gestalt to confuse people with it, right? But Escher deliberately did that, right? He wanted people to be confused, and that is what his art is all about, right? So, you are focusing on the foreground, and suddenly, the background becomes the foreground, and so on and so forth, right? You kind of jumps between. Okay, there is this ambiguity between what is foreground and what is background. Common fate again, continuity. Okay, so this is how some of the Gestalt principles can determine what is the organization that you have to choose. Okay, so this is the same data set, same scatter plot that I showed you earlier between these 20 cars and their fuel efficiency, right. Now they are now on the y-axis, and they have used a reverse alphabetical order to display this data, right, starting from Volvo all the way to AMC Javelin. So it is easy to search and find a particular car that you are looking for, but then the representation is all over the place, right, and then you are not able to figure out any kind of order in this, or how does one compare with the other, right. You are for example comparing this point in this, it is so hard because they are so far separated, right. So a better organization would be to which uses the law of continuity. Can some way I can continuously represent this point. What is the organization that would encode a continuous representation of that? Okay, would be this one, right. So based on cars arranged according to fuel efficiency. Okay, so you have the least fuel efficient cars to the most fuel efficient cars, right. Now, finding the car that you want may be a little bit longer to do that, okay, but that is okay because now you can read every data point with respect to the other data point, right. You can figure out where the car that you are looking for, where does it lie in terms of this fuel efficiency, and how does it compare with the car that you might have in mind. So, we have used these principles quite extensively in our own data visualizations that we did at the lab, and found out that to be a lot more effective. We tried multiple organizations, we arrived at this. So, this is a visualization of the nota votes in a constituency and where does it lie in respect to the winning margins. Okay. So, this is the 2006 assembly elections in Tamil Nadu. And this is an interactive map. Right now, it may not be so obvious as to what insights it is, but you can interact with this map. So, they assist with assembly. Okay. So, most of Gestalt laws allow you to assemble well. Okay, so let us see here. Now, this is the same chart, same data set, that compares miles, the fuel efficiency versus the weight of the car, right. So, you have this bunch of these things, still a lot of data. How do you now simplify it and make this data make this data more accessible, right. Maybe you can introduce a third variable, right, which is the cylinders. Okay, the cars also have this additional parameter attribute called the cylinders. Cars come in 4, 6 or 8 cylinders, and then once you plot that information using color, right, because they are 2-dimensional, there is a bivariate data, now it becomes a trivariate data. Okay. Cylinder is the third variable here. Okay. So, then you can immediately notice that the smaller cylinders, the less number of cylinders, the more fuel efficient it is, right. So, these are the muscle cars, right, the 8-cylinder cars are the muscle cars, right, which is like extremely powerful, but they are also consume a lot of fuel. Okay. So, they all they are also heavy. Okay. So, they are heavier, they are more powerful, have more cylinders. Okay. So, this is one version, maybe the first cut of that. You do this, this insight comes through very clearly, and then you do this one, right. Suppose color is not available to you as a channel for representation, right. You have to work with only black and white, for example, right. So, because these are what data is the type of number of cylinders. Okay. It is an ordinal data because it goes from 4 to 6 to 8, but then you can also think of it as 3 categories, right. So, categorically you can represent using 3 symbols, but we can also come up with symbols that can indicate the order, shapes, right. Maybe I can use a square, a hexagon and an octagon, for example, right. So, it is not only it can show these things to be different, but it also shows that they are 6, 4, 6 and 8. Okay. So, okay, I do this, then it's still not visually, it does not visually clarify. There are overlaps and other problems. So, maybe instead of solid shape, I use an outline shape. I end up at this thing. I solve the problem of overlap a little bit, but still it introduces additional visual problems. And I try a different encoding altogether, such as this, for example. Now, this is confusing because the overlapping 8s and 6 look like 8s or some other number and so on, right. So, that doesn't work, immediately throw this out, and then I use color, and then this outline seems to be better, and then I also introduce slope graph, right, to also show how dramatically at what rate this thing falls. Okay. So, you see the 4-cylinder cars are most efficient if they are also lighter. Okay. And the moment it increases in weight, you see. So, this is the steepest drop, right. So, which means that in order for a car to remain fuel efficient with less number of cylinders, it also necessarily have to be light in. So, you want to go for if fuel efficiency is the most important concern, you want to go for a 4-cylinder car which weighs very less, right. If you are going for a 4-cylinder car that is heavy, you might as well go for a 6-cylinder car which gives you more power and probably as fuel efficient as it is, right, because you see the overlap here, right. So, these are better, right. same fuel efficiency, right, but more power, right. So this is preferred. Okay, so this tip is less and this is the less. Okay, so once you get to 8 cylinders, the weight does not have too much of an effect. Okay, so it's kind of goes between say 12 to 17 or so. It falls between about 12 to 7 miles per gallon. Okay. Okay, so that is you see that the several iterations kind of lead to more and more it becomes more and more insightful and as well as easier and easier to interpret. Okay, so there are some encoding semantics. The visual encoding means something, and this is from this book called Visual Thinking for Design by Colin Ware. He says that intuitively we understand these symbolic representation as meaning this. Okay, so you have these kind of small shapes defined by closed contour, texture or color or shaded. We think of them as objects, ideas, entities or nodes. Okay, spatially ordered graphical objects, related information or a sequence. In a sequence, the left to right ordering convention borrows from the Western convention of the written language, right. So again, this is all convention, right. So if you want to break it, then you have to be careful that you have to know that you are breaking these conventions, right. So when you rather than thrown like that, if it is ordered like this, we perceive it to be some kind of there is an order, right, and then we will always see it from left to right because we come from the Western reading tradition, right. Similar, so if a graphical objects in proximity means similar concept or related information, graphical objects having the same shape or color, similar concepts or related information. Okay, so you can achieve either by shape or by proximity also. Size of the graphical objects, height of graphical objects relates to the magnitude of whatever it is, right, taller, higher, more fuel efficient, okay, heavier. Okay. Shapes connected by a contour means related entities or paths between entities. Thickness of the connecting contour, the strength of the relationship. Color, texture of connecting contours, the type of relationship. Suppose you want so different lines could mean we have seen that dotted line versus solid line, right. So here there are even multiple variations of that, like a zigzag line, dotted line, solid line. They can mean different types. Shapes enclosed by a contour or a common texture or a common color background, they are contained entities or related entities. Okay. Nested regions, partitioned regions are hierarchical. Okay. Attached shapes or parts of a conceptual structure. Okay. So these are all how everybody thinks, okay, and these notations are known to us because we have been trained in this, right. So we can use these things because when we use these symbolic representations, people will see them as this, and some of them are using directly Gestalt, like the proximity and the enclosure and all that. Okay. So okay, so that's all about assembly. And the third and the most important thing is estimation. This is okay. Let's quickly go through it. It's not a lot. So there are 3 levels of discrimination. I might have written this on the board. You can recall it. The 3 things. One of the 3 things that we are doing, or a combination of more than one, we are doing it. We are discriminating visual elements. Okay, simply that x is equal to the x. These are similar. These are different. Right. We are ranking them, and we are doing a ratio. Okay. So here is where the quantitative part of the data type comes here. Okay. So Tufte said that at the heart of quantitative reasoning is a single question compared to what. Okay. Usually this is a question that drives most of visualization. Compared to what, right? You can say that IIT Bombay generates 2 tons of garbage every day. Now that information is not very useful to understand unless you compare it with something. Okay, compared to what? Okay, compared to another similar entity, another IIT, or rest of Mumbai, or a colony inside Mumbai, or a society which has a similar type of population. We do not know it. Right? So it's all about compared to what, or it could be even with itself, but in a different time period, compared to what it was generating 20 years ago or 10 years ago, and so it is all about comparison, the first and the first. So bluntly or blindly, you can ask this very first question in any kind of visual analytics you are trying to do. Just comparing, compare to what is it? Okay, so again comes from this, so Cleveland and McGill did empirical studies to figure out what are the elements, visual elements that are most effective for encoding data. Okay, ordering elements tasked by accuracy according to theoretical arguments and experimental results. So the rank there from 1 to 7 goes from the most effective to the least effective. Okay, positions along common scale are the easiest. Okay, and so if you want to communicate something, the most important insight, use position along a common scale, because that's the best way. Okay, you can do discrimination, you can do ordering, as well as you can do ratioing much easily. Okay, position on identical but non-aligned scales is the second most, length is the third most, angles are fourth, slopes, I don't know what's the difference between angle and slope. Okay, area, you can see that it is less effective. Volume is harder, density, volume density and color saturation, color hue, they all come below that. So the most important thing is the most important measurement should exploit the highest ranked encoding possible. Okay, so this is the same thing. Length, angle or slope. Okay, angle or slope are basically the same thing, not two different. Area, volume, density, color saturation have the same ranking, and then color hue is only for categorical data, right? So it's kind of treated separately. So I've used channels here, right? So where does this come from? So we use something called a marks. These are geometric primitives like a dot or a line or a shape, right? These are primitives. Channels are the appearance of these marks, right? So for example, position, vertical, both, color, shape, tilt, length, area, volume. Okay, so this is the same thing but visually represented. Position along the common scale is the most effective. Unaligned scale, the second. Length, angle, area, 3D or volume, color luminance and color saturation have the same ranking. This equally effective. Curvature, volume, and the ones on the right are all used for categorical data, right? Like shapes, color, hues, and ones that are moving versus not moving, and then shapes. So in terms of effectiveness, from the best to the least, so encode the most important attributes with the highest rank channels, match channel and data characteristics. So if it is categorical data, then you cannot use any of these other things, okay, because they imply some other meaning, right? Similarly, if you have a quantitative information, you cannot use color hues for them. I think this is the chart that Rasagya showed. It's a kind of a summary of the same thing, and specific to the type of data. I'm sharing these slides, you can take a look at them. Okay, so that is the end of the last slide. Any questions? So I want you to think about this, when you're doing the redesign of that, right? So first of all, check, what data that the designer of the original graphic tried to do, and there has been some kind of a thinking about how they want to encode it, right? We have seen multiple visual attributes here in this lecture, and then are there other ways by which it could have been encoded, right? So this is what about the redesign exercise is all about. Most of the time, especially the Hindu data point and all, it's all done by artists, graphic artists, like general newspaper layout artists, but not people who are trained in visualization design. So you will find a lot of scope for improving them, okay? And sometimes they are also determined by what kind of tool that they are using, okay? And the Hindu data points, a lot of their visualizations are done using Flourish, so they all look very similar, right? So they will do whatever Flourish offers them, that's it. They will just dump the data there, whatever Flourish spits back is what they will present. So generally not so good. But the people in the data team in the Hindu are really good, okay. So what I do is, after every year when this exercise is concluded, I send them to the editor of the Hindu, and then he looks at it and gives me comment about, so they know that we are doing this exercise, and they are very eager to learn from what you guys do, okay. So there is a guy called Srinivasan Ramani, who is the editor, chief editor of the data team. He's also very interested in getting IDC students as interns and all that, but unfortunately so far nobody has gone to work for the Hindu, but it's an excellent organization, right? The challenges and the news media are very different, right? You do not get like this extended period of time to work with it, right? You are given a deadline of 1 hour, you have to finish this because it has to run in tomorrow's paper, right? So the life cycle of this print newspaper stories are extremely short, okay. So you don't have the luxury of doing the perfect job and the best that you can, so you make a lot of compromises, and that can be reflected, that you will see that reflected in the Hindu stories, right. So it's extremely challenging working environment, right. A lot of designers that have got proper training go and try their hand at it, and after some point out they just cannot cope and they don't continue, which is also why this particular industry suffers from the lack of good designers, okay. So they have a problem. They will get designers for overall design and all, but the daily day-to-day thing, right, is very hard for them to do.